Hello brother, today we discuss next topic of electronics control, that is block reduction method. Block reduction method. Okay. So what is that method and what is the block, what is the process, everything we will see in this video. See, what is meant by block? See, as we know the block diagram of control system, there are two blocks. First one is maybe controller, right? Second one may be a plant or process, right? By combining with both two blocks, there is a one common block are indicating with the common alphabet, that is called as a G block. Combination of control and process, right? And once that output of process is again given to the input side, so that feedback block is always indicated by H. Remember one thing. So see, here we are giving input using mixer, so this is the input, right? So always we are indicating input by R of T, right? Again output is indicated by C of T always, right? Sample of output sample of output is again given to the feedback signal called as a B of T, right? And as we know that mixer gives us error signal, right? So this is the whole or a complete block diagram. Okay, in that, see, from input side to directly output side, this is called as a forward path. Okay, and this output to again input, okay, this is called as a feedback path. Okay. Remember this thing. Let's move on the rules. Taking note here. 1 second. Okay. 1 second. Okay. So next page, what is the block reduction rules. So what are the block reduction rules, and which rules we will use to reduce the block? First rule is rule number 1. First rule is called as a associative rule. What is the associative rule? See, suppose there are two mixers, right? These two mixers, right? And these two mixers having some input. Suppose input is R of T, right? Again that given to here like this, and suppose here input is A and here input is B, right? So what is that associative rules told us? Associative rules is very much simple. We can exchange the position of both the mixer. Like this. This is the input R of T and this is the output. But here whatever we mix, see, now we can exchange the position like this. See this, we can shift this here, like this. Okay, that means now it become B and now it become A. So this is the rule, associative rule, where we can exchange the position of mixer front and back. Okay, so this is the first rule of block reduction method. Let's move on the second rule. Series, blocks in series. Okay, As we know, what is the meaning by block? Block means G, right? Suppose here two blocks are in series. Suppose this is the first block, G1, right? And this is the second block. See, both blocks are in series. Both blocks are in series, right? If two or more than two blocks in series, we can combine all series blocks into the single block by taking multiplication, that is G1 into G2. If G3 is here, if maybe there are three blocks, here third block is there, that means we can add here G3, right, like that. So if the blocks are in series, two or more than two blocks are in series, we can put a single block by all the blocks, by replacing all the blocks. Okay, so we can replace all the blocks by the single block only. This is the rule number 2. Rule number 3. If blocks in parallel, if blocks are in parallel, okay, like suppose there are two blocks. First block is G1, second block is G2. Okay, like this. Suppose the two blocks G1 and G2 both are in parallel, we can replace two or more than two, 3, 4, 5, any blocks, but all blocks should be in parallel. If blocks are in parallel, we can replace all blocks using single block, and the blocks we are making addition here. Addition. Why addition? Because blocks are in series, parallel. If blocks are in series, see G1 and G2 in series, so we can put G1 into G2, right? Here, if G1 and G2 are in parallel, we can put G1 plus G2. If again one more block is there, suppose this is G3 here, then we can add here G1 plus G2 plus G3, like that. Okay. So this is the rule number 3, where we can, if the blocks are in parallel, we can put a single block by replacing all parallel blocks. Okay. Let's move on to the next rule. Elimination of feedback. Elimination of feedback path. Feedback path. So as we know, what is the feedback path? This is the forward path indicated by G, right? And here we are connecting mixer, input, and this is the feedback path, right? Okay. If we don't want this feedback path, we can replace everything by eliminating feedback path. But what are the changes you see? Suppose this is the positive, this is the positive, right? Or it may be a negative, right? So what is the replacement? Replacement is very much simple. Replacement is, see, forward path G divided by 1. See, this is the plus, right? This is plus, that means it becomes minus G and H. If it is minus, see, I am just changing the color to understand. If it is minus, then it becomes plus. Okay, just understand one thing. This is the elimination of feedback path, where we can eliminate the feedback path, that is H path, using this rule. But after elimination of feedback path, formula becomes G upon 1 minus GH. If feedback is positive, formula should be in negative. If feedback is negative, formula should be in the positive. Okay. Next rule. Shifting of summing point. Shifting of summing point. So what is the summing point now? See, suppose this is your summing point, right? Where two inputs are added here. Suppose this is the R of t input and this is the X of t. Okay, and after summing point there is a block called as a G, right? If we want to shift that summing point after the block, okay, we want to shift the summing point after the block, means here, right? Then what to do? What are the changes? The changes are very much simple. See, we want this summing point after block, right? That means R of t is as it is here, and this summing point we want here, right? X of t is as it is here. 1 second, okay? We can shift the summing point after the block, but changes are very much simple. We just add block in the summing point like this, X of t. See, here summing point is crosses the summing point. See, this summing point crosses this block, G block, right? This G block is crosses, right? And it is shift after the G block, right? That's why that G block is again add here in the summing point, okay? Suppose already summing point is in after the block, and this is the X of t, right? Suppose this summing point is after the block, and this we want in shift in the before the block. We want this summing point before the block. What to do? We can shift this summing point before the block, okay? But what will be the changes? See, the changes are very much simple. Changes are 1 upon G should be added in the summing point, 1 upon G. See, when we shift after the block, only G add in the summing point, and when we shift before the block, 1 upon G should be added, okay? Next rule, number 7, shifting of takeoff point. Shifting of takeoff point. What is the takeoff point? See, suppose this is the block. Suppose this is the block, right? And takeoff point is here, like this. This is the X of t, right? This is the takeoff point, and this is the R of t, right? This is the takeoff point, right? If you want to shift this takeoff point after the block, what to do? We can shift this takeoff point after the block, but what should be added in the takeoff point? See, this is the G. Takeoff point is now shift after the block, right? We can shift easily, but what will be the changes? Changes are very much simple. We should add 1 upon G into the takeoff point. Okay, 1 upon G into the takeoff point, right? And suppose we want to shift takeoff point before the block like this. Suppose already takeoff point is after the block, okay? X of t, okay? Now we want this takeoff point before the block. What to do? We can shift the takeoff point before the block, but what will be the changes? Changes are very much simple. Only here G will be added. G will be added, okay? So see, when 1 second. See, when we shift summing point after the block, only G add. Before the block, 1 upon G add, right? And when we shift takeoff point after the block, here 1 upon G add. And when we shift takeoff point before the block, only G add, okay? So this exactly contrasts with the summing point and takeoff point. Okay, so these are the formulas which are required to solve the numerical, block reduction numerical, okay? Let's start with the first numerical. The example is find C of S upon R of S, okay? See, C of S means output, R of S means input, so we can call this as a transfer function, right? And the diagram given, the already given diagram, so diagram is like this. see the diagram given. This is the G1, G2, G3, H. Okay. Again mixer used there. So mixer, see, it is came from like this. This is again forward path. Okay. This is the positive. This is the positive. C of S, right? And from here to here, okay, this is the negative and this means positive. This is the R of S. Okay. See, in the diagram they are giving a total 2 forward path, that is from G1, G2, and second forward path is G3, right? And one feedback path, that is H. Okay. So in this example they want transfer function of given circuit. Let's start with the transfer function. I just want to change the color. Okay. So transfer function, see what to do. We have a rule in front of you. There are rules available. So we have total 8 rules. Which rule is applicable here? See, which is the simplest step. See here, G1 and G2 both are in series. See, both are in series. Once both are in series, what we do? We can put a single block with the multiplication of 2 blocks, right? So see, this is the single block we can replace by 2 blocks, and we put here G1 into G2, right? And again remaining things are as it is. This is the G3. This is the G3, right? And it goes to the mixer directly. Okay. And then one more feedback path is there. Feedback path is from output to the input. Okay. So see, remaining structure is as it is. This is the R of S. This is the C of S. Remaining structure as it is. Okay. Now again, what to do? What is the next step? See here, we get 2 blocks are in parallel. See this one dotted section. This one, 2 blocks are in parallel. Okay. So rule number 2, combination of combined block in parallel. So G1, G2 and mixer. So we put G1 plus G2 only, right? See, now these 2 blocks are in parallel, G3 and G1, G2. This block and this block, both blocks are in parallel, right? So both blocks in parallel, that means we can put addition of both the blocks by replacing one block only, right? So this mixer is as it is here, right? Now these 2 blocks are add together, right? So see here, G3 is add here, right? And this is also add. So replacement should be in addition form, right? So G1 plus G2 as it is plus G3, right? And there is a feedback path, H path from the output, and here it is the negative, right? This is the positive, right? This is the R of S and this is C of S. Okay. See what we are doing here. We are just putting a parallel rule and replace all these 2 blocks, that dotted section here. This dotted section we are replacing in the single block. Okay. So next one is, see what we do. See, there are this is the forward path, this is the forward path, and this is the feedback path. It is not forward path. See, parallel combination is only possible in the forward path, 2 forward paths in parallel, right? So this is the first forward path and this is the second forward path, right? So likewise we can use parallel rule, but now here we can't use parallel rule because here one is forward path and second one is the feedback path. So rule number see, transfer function, elimination of feedback path, right? Elimination of feedback path, what happened there? So elimination of feedback path, with G and H are there, so we can put G upon 1 plus GH, right? See, this is the minus, so our function should be in the plus. So just replace this everything using the single block only. G forward path. What is the forward path? G1 G2 plus G3 is the forward path divided by 1 plus. Why we are taking plus here? Because this is the minus, right? So plus forward path. What is the forward path again? G1 G2 plus G3. This is the forward path into feedback path. What is the feedback path? H. Okay, and this is the C of S. This is the R of S. Okay, so what is the C of S upon R of S? What is the C of S upon R of S? C of S upon R of S is equal to G1 G2 plus G3 divided by 1 plus G1 G2 plus G3, okay, into H. This is the transfer function. This is the transfer function, or this is the ratio of output upon input. So likewise example we can solve using the simple rules. Rules are in front of you. You can put all rules on the single page. That means when you practicing the numerical, that time you can put your formula easily from your rules. So write down rules likewise only and try to solve more example. Okay, thank you.